Here's your Unit 5 study guide. Number 1. Here is a story. Noah was at home. He got on his bike and rode to his friend's house and stayed there for a while. Then he rode home again. Then he rode to the park. Then he rode home again. Circle the graph that represents the situation. Okay, so to begin, Noah was at home. So look at all of your graphs and notice this one here, Noah is not at home. So already graph B is out. But in graph A, he's at home. And graph C, he's here at home. All right, step 2. He got on his bike and rode to his friend's house. Okay, so he's going to get on his bike and ride to his friend's house. So that could be here, and that could be here. And he stayed there for a while. Okay, so that would be no motion. So graph A, stayed there for a while, that still fits, and graph C, that still fits. Then he rode home again. So that would be a return to start. Whoop, right there, he rode home again, where this one is increasing at a steady rate. So C is out. Let's go ahead and finish it off. Then he rode to the park. Okay, so that would be here, riding to the park. And then he rode home again. That would be here. So it didn't really mention this part here, that he stayed at the park for a while, but for sure, graph C is out because there is no return to start. So final answer, A. Okay, next we're going to identify if the table is a function and why. So remember, for it to be a function, every input has exactly one output. Our inputs cannot repeat. So when I look at table A, I notice that all of my inputs are different and they have their own outputs. So there are no repeaters here in the input. So yes, this is a function. And then now I have to tell why. Okay, so I came up with a reason there. I said that table A is a function because each input has an output. I also added that no input repeats. Let's do the same for table B. Okay, so table B, again, I'm going to examine the inputs. And oh boy, okay, I can see the 4 repeats and the 1 repeats. So this is not a function because those inputs are repeating. So it's saying 4 is -2, but 4 is +2. So the input cannot have 2 different outputs. So this is not a function. And now I'm going to explain my reasoning. Okay, so I said for table B, it's not a function because the input of 4 has 2 outputs and the input of 1 has 2 outputs. So not a function. And now let's examine table C, our input of 1, an input of 2, an input of 3. This one is a function because they have all different inputs. 1 is paired with 0, 2 is paired with 0, and 3 is paired with 0. It's okay if the outputs are all the same. That's still okay. That still makes it a function. So this one is a function because for every input, there's exactly 1 output. Okay, so a reason similar to this. Table C is a function because every input has 1 output. Okay, now we're going to do the same thing, but it's with mapping diagrams. So we're going to circle all the following that represent a function. Okay, looking at number 1, again, use that idea of focusing on the inputs. So we have an input of 10, 20, 30, and 40. Those are all different inputs, so they're paired with an output. So this one is a function, or you could circle it. Okay, number 2. Now here is like kind of that classic example of when it's not a function. This one is not a function because 3 has different outputs. If I saw this on a graph, okay, if I graph it, it would look like this. I go over 3, up 0, so here. Over 3, up 2. Over 3, up 4. Over 3, up 6. You see how all of those outputs are on the same line as 3. So if I connected those, or if I did the vertical line test, which we talked about, let me show you that. Okay, if I take a line and go across the graph, you can see it's hitting the line in 4 different places, so this is not a function. Okay, and now checking out the next example, I see here how the 2 is paired with 2 different things. So this one is not going to be a function. I also want to show you that on a graph. Okay, so if I graphed it over 2, up 20, so that would be right here. Over 2, up 40 would be here. Over 4, up 40 would be here, and over 3, up 30 would be here. And then if I tried that vertical line test, when I brought this line over, you can see when I get to the value of 2, 2 points are on that line. So it does not pass the vertical line test. So it's not a function. Okay, moving on to the next one. Again, examine that input. So we have negative 1, we have 0, we have 1, 2, and 3. All of these are different inputs, so this one checks out. This one is a function because they're all paired with different outputs. Okay, same idea here. Look at this ordered pair. Is this relation a function? This is your x value, that's your input, there's your output. So look at these 3 numbers. Are they all different? Does every input have exactly 1 output? So this one is yes, a function. Number 5, is this a function? Look at the graph. Okay, so let's try that vertical line test. As I bring the line across, okay, that point hits the line once, but when I go right here, boom, boom, it hits the line twice. So because it hits the line twice, this is a no, not a function. Okay, so switching gears a little bit, this is a function. I can tell that already because we have different inputs here, but that's not what it's asking. It's asking, is it linear or non-linear? So if it appeared on a graph, would it make a straight line or would it like make a curve? So a couple different ways you can think about this. We can look to see if it has a constant slope or rate. So what's the change in y over the change in x? You can see the change of y, it's increasing by 3 throughout the table. And then the change in x, it is also, it's increasing by 1 each time. Okay, so because we have the same rate throughout the table or the same slope, then it's looking like it's going to be linear. I could also double check that by graphing it. So I'm going to go ahead and plot these points on here. And let's see what happens. Okay, so my first ordered pair is negative 1, 8. So I go back 1 and up 8. 1, 2, 3, 8. So about here. It's right there. Okay. And then 0, 11. So 0 and then 1, 2, 3, 4, 5, 6. So it's going to be right here. And then over 1 and up 14, 11, 12, 13, 14. So up there, I fell off the graph, but I can see that it is forming a straight line, so I will confirm that this is linear. Okay, so it's a constant rate throughout the table, and I graphed it just to double check to see if it made a straight line. Okay, number 7, choose the graphs that represent linear functions. So linear functions are going to be straight lines that are also functions. Okay, so A is a straight line, and it also passes the vertical line test. B is linear, and it passes the vertical line test. C is nonlinear, so that one's nonlinear. And then D, it's linear, but it's not a function, because if I, grab a line and I try to do that vertical line test, you can see all the points hit the line. So this one is not a function, so we can't say it's linear function. It had to be linear and be a function. So just A and B for number 7. And finally, we're going to complete the table and we're going to write an equation. So let's remember how to do this. I am noticing a pattern here. So it's in increasing, it's going 1, 2, 3, 4 right here. And then if I go across the table to go from a 3 to a 24 and a 4 to a 32, I know that I can multiply by 8. So times 8 times 8. Okay, so 1 times 8 is 8, and 2 times 8 is 16. So every time I am multiplying by 8. So remember, when we were writing equations, y equals mx plus b. Okay, so we know our rate. We know we're going to times by 8 each time. So I know y equals 8x. Now, is there a b? Is there a y-intercept? That would be the same as if there was a 0 on this table. If I did 0 times 8, I would get 0. So there is no y-intercept, so my equation is just y equals 8x. And that brings us to the end. Please reach out if you have any questions or you're confused about anything. Thank you.